Hi everyone! Today we are making the stable free radical of 2266 tetramethyl 4-piperidone, or as known as 4-oxotempo. First thing we're gonna do is freebase the hemioxylate salt of the piperidone. So we're gonna weigh out 0.59 grams of sodium hydroxide. We're then going to dissolve this in 5 milliliters of distilled water. Then we weigh out the tetramethylpiperidone hemioxylate. This one I made some time ago came out to be 2.5 grams, and it was then dissolved in 20 milliliters of distilled water. The beaker was then put on a hot plate. A magnetic stirrer was added, together with a thermometer. The sodium hydroxide solution that we made earlier was poured in to deprotonate the piperidone and release the free base form. After a bit, the solution was tested with pH paper and it came out basic. This is going to be our catalyst for the reaction, sodium tungstate, a salt of tungsten 6+, widely used in oxidation reactions. 400 milligrams of it were weighed out and then added to the main reaction mixture. Then 4.5 milliliters of 35% hydrogen peroxide were dropwise added, keeping a careful eye on temperature. Our prayers to the chemistry gods played out good, as the temperature spikes were absurdly low relatively to my expectation. But karma struck down as this started to foam up like crazy, and I realized why. The papers mentioned something along the side of anti-foaming agents. Anyway, we should now explore the mechanism of this reaction. I'm saying we should, as I didn't really find any information about it. But as soon as I'll find anything, I'll release a video about it, together with a EPR analysis of the product. So we'll now proceed to the solvent extraction. We'll use a DCM chloroform mixture to extract our product from the reaction mixture, while all these salts will stay in the water layer. In the organic layer, the precursor impurity will also be present, but we'll deal with that later through recrystallization. Separation of the product by washing the aqueous solution with chloroform was really a pain. After shaking, foam and emulsions were really hard to break down, but after a ton of time wasted on it, a deep red solution was obtained, later dried with anhydrous magnesium sulfate. The solvent was distilled off under reduced pressure with a short path vacuum distillation apparatus. When only a small volume of liquid was remaining in the boiling flask, hexane was added to help distill DCM, which can be more difficult to strip off later on. After all the solvent was distilled off, a viscous deep red liquid was left in the flask. It's also really fun to do lab stuff because you always see something new happening. For example, this interesting phenomenon of some droplets of the reaction mixture hovering off the solution, like it's some sort of flying UFO or something like that. This was poured in a beaker, and the product was crushed out with cold hexanes. The precipitate was filtered on a gooch and washed again with cold saxane. The washed precipitate was put in a flask, gently heated, and a hard vacuum was pulled to strip off any remaining solvent. The product didn't undergo any further purification because tests and sublimation were unsuccessful, so it was just weighed and stored. The total weight was 560 milligrams, resulting in a magnificent 27% yield. The product can be observed as a crystalline orange solid substance. Anyway, thanks for sticking around. Hopefully we'll follow a video with the mechanism of the tungstate catalyzed oxidation of the amine, EPR and UV analysis.